This is Elektor. My name is Jan Buiting. I'm the managing editor of Elektor magazine. That's not so terribly important for this session today. The importance is on Retronics, retro electronics if you like. And I hope to do a webinar together with you. It will not be chronological, so let's get started. But let's not get started straight away. Let's have a look at the first picture. It's myself repairing an old radio from 1958 using my set of old test equipment, mostly from Philips. Now, if you think that's a real laboratory, you're as sadly mistaken and happily mistaken at the same time. Because, as you can see, behind the scenes, this entire laboratory was built as a mock-up, especially for this seminar and for a book on which I'll be telling you a bit more later. You can see my faithful staff photographer Janine taking my picture in the very modern Elektor labs, but this is a special scene we made with my old equipment. So there's a lot of people working behind the scenes with Retronics. I'm always associated with Retronics as a person, but I can mention at least 10 people working happily together with me, and they are supporting me, which is very much appreciated. Retronics, how it all came about. I'm always often asked, Jan, how did this all started? Well, it started in 2004 as a challenge. I was just challenged by some major editor to write an article about some old equipment I had available, and I said, okay, let's do it. And that used to be the Heathkit TC2P tube checker, which I'll discuss in a minute with you. I was strictly told to cover one page only in the magazine, and I was faithful to that for many, many years, and then it extended to 2 pages, 3 pages, 4 pages. Initially it was all my own writing and sourcing of the equipment, and later on I got assistance, very, very pleased with that, from you, our readers. And the first installment was on the Heathkit tube test, as you can see. I was often asked for a series philosophy behind Retronics. Well, there ain't any. That is to say, it was back annotated, as you can see. I had to work out a philosophy just for the lot of red tape within this company and managing people and so on. So let's just see what the philosophy is. Elektor is not typically associated with vintage equipment or electronics history, old equipment, boat anchors, that sort of stuff. Elektor is very much in front of technology, very forward with microcontrollers, embedded stuff, that sort of thing. So I thought, well, let's balance that for a bit and do old equipment as well. One of the very fortunate events was that our offices were relocated in 2006. It was sad as well as happy event. Because sad because a lot of stuff got thrown away in the bins and in the skip and was carried off, and I was allowed to pick like 12 items from the old stock especially for Retronics, and I picked 24 or something. My personal interest is with tubes. I come from a tube era. If you look at my date of birth, it's year of birth, it's 1958. And I've been on the Elektor staff since 1985, so that's quite a history. If you think that Retronics caters for old readers only, you're mistaken, happily mistaken again. Younger people like it as well, judging from the feedback I get. I'd like to stimulate the so-called e-comeback, electronics comeback. If you've been out of the industry or out of this profession for a while, please come back to electronics through Retronics. Stick with your old equipment and get it out of your attics and see what happens. I'm trying to create a kind of community which is working very well. I'm very pleased with the results so far. I have a small budget actually allocated by my managing people, like 500 euros a year to get equipment back from you or to purchase the occasional item. My live performances are not well known, but they do exist. I've performed Retronics live shows in Germany and in Holland, and I look forward to doing them in many other countries as well. Hopefully the US and the UK as well. Retronics is not a closed session. I am utterly and totally open to your articles, your suggestions, and what have you. My sole and single aim is amusement and fun. I am not an instructor. I am not a technical guru. I am not a total and utter repairman. My only aim is to amuse you with the stories and, you know, get a smile from people, our readers. There is no chronological order in Retronics. You are not at school at this time, and there will be no science history. There are many other books, many other websites to find that sort of stuff. The first thing I uncovered for Retronics was the Heathkit TC2P. I've purposely called it a tube checker. It is not, I repeat, not a tube tester. I know very well what a tube tester is, and this little thing is a tube checker only. I found it at a booth sales, I think some lawn sale of car parts, motorcycle parts, old engine parts, and that is very fortunate because the people at these sort of events haven't a clue about electronics, hence the low price. You can just say, well, this is an old piece of equipment, it's worth nearly nothing. Let me just give you $10 and you can walk away with it. And that actually happened with this little tube tester. As you can see, the surface is bright, clean, looks spiffy, but I've purposely left a very small corner uncleaned, which is here at the right arrow, to show, if you can look very, very carefully in the picture, there's mold on there, there's white debris, dust, scratches and so on. The thing is powered by 110 volts, US standard 60 Hertz. It does have a lot of limitations. Basically, it requires mechanical settings. You have to read the tube type from this chart, which has a massive wheel to turn, which is very nice to see in operation. Again, it does emission only, so it's a quick, good, bad indicator, no more really. You can see the meter. I had to restore the meter because it was frozen by rust. Heathkit, the legend, merits a separate webinar in itself, I think, because it's such a famous company. Now, before moving on to analog multimeters, I'm asking Patrick, my cameraman, to watch what happens. I'm going to show you some of the stuff here at the Elektor attic, which is behind me, and I've got another surprise for you in a minute. If we look at the small storage here, it's improvised. There's a lot of old audio equipment here. There is an SSB 80 meters receiver, which we published many years ago. A very notorious FilmNet decoder from 1989, if I remember correctly. Some more audio stuff. A stereo bass with expander, it's called, an analog multimeter. Some more audio stuff like a vocoder to get your chair voice, you know, that sort of Donald Duck effects. The Mugen hybrid amplifier is here. A satellite TV receiver, Elektor Scope, very famous project from the past. I have to move my chair for a sec to move over here to some more test equipment from the 1980s. This is just to give you a brief impression. And then the total and utter monster called Formant, our synthesizer from the late 1970s. I'm in happy company at the moment of a Tektronix 564 storage oscilloscope, which I'm going to discuss in a bit more detail a bit further on during this webinar. And this is more tube, radio, equipment which we have gathered. And my possessions, if you like, are just about range to this range. Okay, let's continue with the webinar on analog multimeters. On your screen right now are two pristine multimeters from the late 1960s, early 70s. The left one is a Philips one, the right one is a Simpson one from the US, I think. Let's discuss a bit about accuracy of these old beasts. Younger people, you know, howl at accuracy, but I dare them in terms of percentage accuracy if you know how to use these instruments properly. I was once challenged and I achieved an accuracy, reading accuracy of 0.5% compared to a very expensive fluke something. They do have advantages with respect to the DMMs, these old AMMs as I call them. Specifically, you can watch a trend. If you are aligning an analog circuit and you want to know the trend, you know, if you're moving, your needle is moving into the right direction or the wrong direction, try that with a DMM, with all these rolling digits, and you'll see the advantage of an analog multimeter. They also have disadvantages, of course, you know, the ease of reading. You have to switch the ranges, you have to know what you're measuring, which may be an advantage as well. And so my advice is always keep at least one of these old beasts in your shack, because you never know what to align in the future, maybe old equipment. AMMs do have hidden features. From my own experience, I'm a radio amateur, and for example, to adjust a transmitter, you can just put one of the leads of an AMM vertical and tune your transmitter for maximum field strength. You can use any range on the AMM. It makes absolutely no difference if you're like measuring in the 300 volts range or the 50 microamps range, because this RF signal is induced directly into the meter, into the moving coil meter and the circuitry. Moving on, everybody, to microcontrollers, because microcontrollers, in my opinion, are vintage too. Here's the Elektor Junior computer. It wasn't the first Elektor microcontroller system. If you look very carefully on my table, right here, is that visible, Patrick? Yeah. Right here is the SCMP, which was a predecessor to the Junior computer. Here's the book. So the Junior computer wasn't the first microcontroller system Elektor published. Many people think that's the case. It isn't. It has a 6502 microcontroller, incredibly famous. The success factors of this Junior thing were basically very simple explanations in the articles. Simple software, everything was printed, open source, and you know, it was a huge success because basically everybody was able to build their own microcontroller system. There were competitors, of course, the Kim system, I remember correctly. Perhaps some readers may assist me in the Q&A section with some competitors of the Junior computer. The extension boards were famous. You could add as many as you like using a bus system, and many people devised their own extension boards. The books were famous too. We'll have a look at that in the next slide. Records and cassettes existed at the time to produce the software and distribute it. The sales volume is a staggering 20K estimate. Those were times when we sold like thousands of these Junior boards. And my special thanks go out to Dennis Fitzpatrick for supplying me with a vintage Junior, which got thrown away, I'm sorry to say, like 6 years ago. This is the Elektor Junior board seen from the solder side, the not so very exciting side, but it's still the user side, as you can see, with the keyboard and the display. Very powerful little thing, and very educational and a very pleasant sort of thing to work with for many, many readers. And I hope there's many of you on the audience enjoying this, to see this. The Junior was supported by books and even 45 RPM records to distribute the software. The books are very rare at the moment and sought after even on eBay. Moving back to test equipment, again we had the analog multimeters, and you want an oscilloscope as well. During 1975-77, Elektor published two versions of an oscilloscope, with using transistors and of course a CRT, a cathode ray tube. So there's at least one tube. In two versions, as you can see in the picture, large and small. So you may wonder, why build a scope in the first place? Why not buy one on eBay? Well, eBay didn't exist in 1977 and test equipment was horribly expensive at the time. So there was a good alternative in building one yourself. The design of this scope was a story in itself. The lab people were very much pushed and pressed to come up with a design by the publishing management, and they came up with a virtual copy of a commercial oscilloscope, to put it in modest terms. That was discovered by the editor-in-chief at the time, and he sent everybody back to the drawing board with strong words. And in like 3 weeks later, you know, somebody from the engineering department at that time came up with a brand new design. And the trick was, it wasn't a brand new design. The entire design was just flipped in terms of polarity. If you have an NPN transistor, take the PNP equivalent and flip the supply rail to negative on the top. So it was an inverted design full of PNP transistors and negative supply rails, and nobody noticed, and it became a huge success. The front panels were available ready-made, ready drilled from Elektor, very high quality products. And the PNP anecdote I've already told you. There are two versions, as you can see in the picture. The smaller one had the famous tube GG732, which was available cheaply at the time. These oscilloscopes were frequent travelers. They traveled from the UK to Canada, to Austria, Italy, on electronic shows to show to Elektor readers. Very nice equipment. There are two of these oscilloscopes right next to me on the bottom, near the bottom here, so we can't show them on camera. Oh, Patrick's got them on camera. That is very nice, yes. They are nicely together, and yep, it's a nice memory, and they still work, by the way. Limited bandwidth, they work. Back to microcontrollers again. As you see, we're flipping between analog stuff, test and measurement stuff, and microcontroller stuff. CDP-1802, spaced out because it was the first microcontroller to leave the Earth. It's not realized by many people. RCA developed this 8-bit microcontroller in 1975-ish, and it was a CMOS microcontroller, meaning it has very low power consumption. Like all RCA, you remember CMOS C4000 series. This is a spin-off from this series. Somebody at RCA, by coincidence or not, we do not know, talked to somebody at NASA in the United States, and it was mentioned that the CDP-1802 has an SOS, silicon on sapphire structure, which means that it is highly resistant to cosmic radiation. And the people at NASA were very happy to hear that, of course, and they said, well, let's put one of these silly, slow microcontrollers in our deep space exploration vehicles. And to be truthful, they still work. Their signals can still be received to this date, like 40 years later. Fierce competition, of course, Z80, 8085, Intel 6502, Rockwell came in later, so it didn't make much of an impression, this CDP-1802, but it is a very charming processor as far as I'm concerned. It appeared later in a computer called Comics 35. It's a very comical name. The Cosmicos system I have described in a separate installment. It's my all-time coolest micro, literally, because it remains cool. My first thing I do when seeing microcontrollers is touching them and seeing if they get hot. This one doesn't. It produces extremely compact code, it is extremely slow, and it is extremely energy-wise, still, after all these years. This is my Cosmicos development system based on the 1802. We call it the European ELF2. Look at the size of the board, the display on it. Bus system is here. Expansion boards are up the back. There's a display unit, very nicely built, and it works like it works a dream. It was a very educational system. Moving back to music, we've already seen the Formant on right above me. It dates back to 1977, and as you can see, we call it the poor man's MOOC synthesizer. The articles, boards and books. The articles covered like 180 pages in the magazine, and they were bundled in books like so, which is rare copies now, difficult to get even on eBay. It's all DIY, all analog for all microcontroller generation viewers. It's modular, it has very strict structure based on modules, which you can extend to your own liking, as you'll see in a minute. It's fully expandable. Now, the next discussion is it a musical instrument or not? I say it isn't. I say it's a generator of soundscapes. You'll see that in a minute and hear it as well, hopefully. The authors were called Mr. Colin Chapman from the UK and one Mr. Eigner from Austria, to whom we are still very, very grateful for producing this wonderful thing. Really, I was going to say instrument, but I'm not. You should check it out on YouTube and hear the most amazing performances done with the Formant. I've got one coming up. Let me have a look. No. First, there's the Monster Formant. As you can see here at the attic, we've been very modest with our Formant. It's just a small unit. Now, Siegfried Bruckner from Germany has like 116 modules built across 3 Formant stacks of piles of equipment. Look at the picture while he's playing it at the Happy Knopping event in Germany. It's 4 feet tall, the whole thing, and polyphonic as well. Look, just mention the URL there on YouTube. It is absolutely amazing to see and hear this thing playing. Okay, people, I hope we've all settled from this awful noise burst from the Formant synthesizer, played by my colleague Denis Meyer from the French editorial department. Back to some microcontroller stuff. Again, this is the Elektor 8052AH Basic, another blockbuster on the Retronics scene, as well as the Elektor general history. There's a nice story behind this because Intel tried to protect, their interpreter running inside this controller. It was a basic controller. You could program it in BASIC, and at Elektor we said, well, why should this be an expensive chip? Let's do the same with an 80C32 and an EEPROM. So we kind of extracted the interpreter from the main Intel chip and put it into an EEPROM for running cheerfully alongside an 8OC32 processor, which is far cheaper than the HH basic chip. Then we got some nice letters from the Intel Law Department from the US, which were suitably ignored. We pressed on with the publication. The interpreter was actually improved, and the people at the end, people at Intel were pleased with that as well, and they watched what happened with the improvements. There's a nice anecdote with this little computer. It is a computer, and it has a push button called BYST, as you can see here on the separate photograph. Now, older readers among you may remember BRST, Big Red Switch Time, on your first IBM desktop PCs. When programs crashed at the time, there was no reset button on these PCs, and you had to flip like the on and off switch at the side to restart your program, and hopefully in a minute or two, a minute or 10. And it was called BRST. Everybody would be shouting, "Dude, BRST again, my program has crashed." So when the programs on our computer started to crash, and they did, believe me, we pressed the reset button and we called it BYST, Big Yellow Switch Time. Back to test equipment, and one of the beasts in the series, one of the blockbusters discussed in Retronics, in my books and in my magazine, is called the 564B, which has a nice story behind it. Well, to be honest, if you don't know this Tektronix scope, or you don't recognize it, you may have to think about your history in electronics, because it's so incredibly famous to have this sort of equipment beside you and to recognize it. They are built like tanks. 1963 is the approximate date of build, I think, year of build. I got it in exchange for some fruit. My neighbor called me and said he had this blue thing in his garage, which looked, he said, like medical equipment, and I noticed it was a tech, and I gave him a bucket of apples, I think, in exchange, and a cup of coffee, and he was very happy, and so was I. There's no memory inside this equipment. The phosphor and at the inside of CRT is used as the memory, and it's erased electrically. It has incredible high standards for soldering and construction from Tektronix. There's a washing saga around that Tektronix used to wash and clean their equipment with water, and that is not ordinary water, that is deionized water of a specific temperature. And they dried their equipment in ovens of like 60 degrees Celsius for 24 hours or even more. I intend to do that at some time in the future, hopefully, to see if that works. The solder spool story. There is a spool of silver solder inside this equipment, which if it's gone, or if you run out of solder, you can write to Tektronix and get a free spool, and it still works after all these years. I've tried that personally. It's a great thing to receive an envelope from Tektronix Corporation with your silver solder to do some repairs on the equipment. The cartoons we'll see in a minute, and you should really check out www.classictech.org if you are interested in Tektronix. But there's more to come. Watch this. This is like opening a Chevrolet bonnet. Look at the construction, the blue side panel, the marvelous construction. Here's the solder spool, by the way, which I'm going to discuss in a minute. Beautiful construction, very nicely made, built like a tank. On the other side you can see the plug-in, partly removed. This is still the 5646B. Made a mistake with the type numbers I see, but never mind. Makes little difference. They all look the same, these oscilloscopes. I hope many of you watching may recognize this from the old days as a student, when in practicing or in classes working with these old oscilloscopes, often fitted on trolleys, because they were so heavy. And if you were unlucky, you had a type with even a fan inside, which made a hell of a noise, if I remember correctly. There you have your solder, a spool with silver solder, courtesy of Tektronix. Courteous warning, all very courteous American style production. So that is what I call engineers for engineers, and which makes me very happy to do this series in the first place, discovering this sort of thing. It's like people at Tektronix hailing back to us from the past. Now, if you think that Americans have no sense of humor, or that they produce dry electronic manuals, have a look at what happened on the last page of the Tektronix manual. Got it, a copy of here to prove that this hasn't been produced with Photoshop or what have you. Actually here, I found this on the very last page of the instruction manual. It's called Washerwoman. As you may remember, I told you it's a memory oscilloscope, which means that the screen can be erased at the flick of a switch, and somebody with a very good sense of humor at Tektronix decided to draw Washerwoman on top of the CRT in the circuit diagram, which I can appreciate very, very much as a kind of engineer's joke. There are more cartoons in Tektronix documentation. Please, if you know any more, inform me by email or what have you. We are approaching the end of this webinar, and I was just going to make you aware of my new book, which is really very, very new because the first copies arrived yesterday. This is my personal copy. I've bundled like 80 something of my stories published in Elektor magazine in a book. It has a very nice layout, I have to say. It was specially made for me by some colleagues, really appreciating Retronics and the way it works in the magazine. Some of the photographs have been enhanced, some have got very much like a sepia background to it, and the texts have also been carefully checked. And I haven't written this book alone. You know, there's contributions from many, many people around the world. So it's called 80 Tales of Electronics Bygones. It makes excellent bedtime reading. I would advise to read one installment or one chapter every day just before you go to sleep. That is for Ties Wijfels too, who's watching at the moment. Ties, I would advise you, not to exceed one chapter a day because it's addictive. And it will last you like 81 days, or even more if you don't include the weekends. If you order the book before February 4th, you get a 20% discount. That is what's been happily arranged by my colleagues in the commercial department, because they like the book very much as well. So that's my new book. It's previously a Dutch edition has already appeared. This is English, and this is brand new and even bigger. It's goodbye from me at this point, but surprisingly I say welcome as well. This is the end of the webinar virtually, but I say welcome everybody who wants to write articles and get them published in the Retronics section. I do not produce this by myself. I don't do this all alone, as you can see. I've already got like 15 authors having written pieces for me, and you can be the next one. So my advice is safeguard your vintage electronics. Be very careful with what you throw away. Write about the stuff. I always say you are the author, and here's my email address on the image. I welcome everything, as you can see, tubes, analog equipment, but also test and measurement equipment, but also vintage microcontroller stuff. Please keep the e-vintage spirit alive, thank you. And as I've already said, microcontrollers are e-vintage too. I like to have coverage of microcontrollers in Retronics as well. Some nice words to learn for today are e-debris. can see it here. And boat anchors, if you don't know what a boat anchor is, look that up on the web. I'd like to repeat a slogan from one of my contributors living nearby in Aachen, and that is, please put a stop to throwawayism. Don't just throw away electronics. Please don't do it. Think about what you're doing before you throw things away. Might be very useful even to spread the word to fellow readers of Elektor. Finally, keep your daytime job, everybody. And it's goodbye from an old hand at radio as well. My call sign is PE1CSI. To close off the webinar, I'm just going boldly back to the first slide. You know, there's a nice picture and it tells a whole story about what happens at the Elektor labs. I'm actually repairing an old radio here from 1958. It's on my desk here. I have a very small power supply. I use a Variac and it's with an adjustable transformer, which I would recommend doing so to everybody because it's safe to start up old equipment slowly and gradually without causing explosions. Small radio, analog signal generators, an RLC bridge, some old documentation, and my trusted stock of old components. Never throw away, NOS, new old stock. And you will enjoy repairing radios as much as I do. And in closing, I can say that the radio is working perfectly since my repair pictures here for this webinar.